Hello class, welcome back to another section of our intensive calculus course. In this class, we are still going to be talking about limit of functions, which we started earlier on. So, under this section, we'll be looking at limit of stepwise functions as well as limit of piecewise functions. Kindly watch this video to the end so that you understand every part of the video. Don't forget to like, subscribe and share as well. So, stepwise function as explained in our functions class, I said these are a form of constant functions which have certain changes or certain decrease or increase. We have given you a throwback, assuming you have a graph like this. A stepwise function will be constant functions in these abrupt changes, while some will come this way, others will come this way, and that. So stepwise function, it looks like staircase, yes. So if you have here this, assuming here is 2, this is the same as y equals 2 as a function. You have another one, you can have another one here. So you have each constant part corresponding to each or corresponding to a different interval. That is stepwise functions. Whilst piecewise function, as I said, is just a single function which has been broken into pieces. You get something like this, and the other parts somewhere. But each piece is being defined over an interval. So this piece has been defined from here to here, while this piece from here to here, this piece. So that is stepwise and piecewise functions. So, back to what we have for this class, limit of functions and limit of stepwise and piecewise functions. We are going to talk about the right limit and the left limit. So, a limit of a function is defined when the right limit L plus is equal to the left limit, which is equal to a value L. So for you to get a defined limit, then it means that your left limit or limit as you approach that point from the left should be equal to the limit as you approach that same point from the right. If it happens to give you different values, then your solution to the limit is simply limit does not exist. That will be your simplest solution. Limit does not exist. Let's take examples to see how we solve this. So let me take one first stepwise function. So I have f of x, and this f of x is equal to one constant value e. I've explained e as Euler's number, and it has a value. Then you have e plus ln of 2, which is also a constant. And this e is defined over x is greater than negative 4. Then this part is also defined over negative 7 less than x less than or equal to negative 4. So this is a stepwise function. And we've been asked to find the limits as s approaches negative 7, as s approaches negative 4, and s approaches 0. So first, let's take limits as s approaches negative 7. Now, in this interval, you realize that whenever you have a number falling in this interval, s is greater than negative 7, but less than or equal to negative 4, then it means that it will give us a constant solution of e plus ln 2. But if the interval falls here, it will give us this. So let's see how we do this. In stepwise function, you need to take your right limit and your left limit separately. Then afterwards, if they are equal, then it means that will be your limit value. If they are unequal, then it means the limit does not exist. So let's see. Limits as x approaches negative 7, then you introduce plus. That is negative 7 from the positive side. So from the positive side, which part of this graph will have negative 7 from the positive side. Remember, here is x is greater than negative 4. S is greater than negative 4. So the values here will start from negative 3, negative 2, negative 1, and forward. Let me write it here. Negative 3, negative 2, negative 1, then forward. Then, when I come to this interval is saying that s is greater than negative 7. Meaning it's going to start from negative 6, negative 5, negative 4, then it will end because it said it's less than or equal to negative 4. But our interest here is that we want to find the limit as it approaches negative 7 from the right side. If I draw any Cartesian plane and I have negative 7, my right side is going to be this side. So if I'm approaching negative 7, then I'm surely going to meet negative 6, negative 5 before I reach there. Meaning this limit will give me the constant value of this. Or the right side will fall in this interval. And that is going to be e plus ln 2 as my solution. Then I move ahead to find limits of negative 7 as you approach it from the left side. Now, from the left side, you realize that we are going to have values here. We are going to have bigger values. That is any number less than negative 7. So you're going to have negative 8 or negative 9, those values. So do we have any interval we can place it here? No. We don't have any interval we can place it here because this constant part is saying that it starts from s greater than this. Then this is saying that it starts from s greater than negative 7. So if you want to find the limit as s approaches negative 7 from the left side, which part do you think it is going to fall? So here is saying that s is greater than negative 7, and that will be only the right part. Then here is saying that s is, so let's see something here. Here is negative 8. If I extend negative 9, and I don't have any, the function doesn't extend to that part. So the scope of the function will not allow us to find the left side of this. So meaning this limit is going to have only right side. It's going to have only right side. And let's see something. So once you have the right side, then you say that the limit here is this. The limit of this piece will give us this. That is in the case of this stepwise function. Now let's check for the negative 4. So limit as x approaches negative 4 from the right side. That is going to give us limit as it approaches negative 4 from the right side. That is going to give us this interval. Because from the right side, you realize that you'll be getting negative 3, negative 2, negative 1. Because let me draw once again. If I have negative 4 here, the right side is going to be here, starting from here, 1, 0, negative 1, negative 2. So to be this interval, and the solution will be what I have here, e. I'll just write my e. Then limit as s approaches negative 4 from the right side. That one is going to be negative. That is going to fall here because this is saying that it's less than or equal to negative 4. So it's going to fall in this range. And the solution is e plus ln 2. Now you can see that the right and left limits are not equal. E is not equal to e plus ln 2. Therefore, the limit does not exist. Does not exist. Now let's move to 0. Limit as x approaches 0 from the right side. So in this range, right side of 0 is going to give us this one. Because if s is greater than negative 4, then you realize that you're going to have negative 3, negative 2, negative 1, then 0. So let's see something. When I take 0, where will the right side of 0 be? If I have 0, the right side will come here. Then this range, s greater than negative 4, goes up to the positive side. So meaning this is going to give me e. as the limit value here. Then when I come to the negative part, or 0 from the left side, I'm going to get which part will be 0, so this side. That is, I'm going to get the negative part, which is the left side of 0, and that will give me, let's see, if I have s is from the left side, if I have 0 here, then I'm going to start from this side coming. So coming from this side, I have -7, -6, -5, -3 in that order. But in this range, you realize that we don't have 0 there. Everything here is negative values. You can't have 0. So this looks like the first one that we did, the -7, which we have only the right side of the limit of the function being played or being functioning. So let's see something. So in this case, we wouldn't use the negative limits, yes. And when you come here to realize that you don't have any left side of the 0. So the negative or the left side of the 0 will even coincide with this part, because if you are coming from any number greater than -4 will also start from here, -4. So the limits, both right and left limit, will all fall here like this. So the solution will also be E, because you have -4, -3, and this is the left side of 0. And once we extend to 0, 1, 2, here will be the right side of 0. So therefore, E is equal to E. Therefore, the limit as s approaches 0 is E, and that is perfect. Now, let's see this side once again for the -7 side. If you have the left side of -7, that one, as I said, this function is having only the left side of it. So these are how we go about by the stepwise functions. Let's take the piecewise function example and see how we do that. So for the piecewise function, you have f of x to be equal to square root of x minus 4, then 8 minus 2x. So once you have square root of x minus 4, then 8 minus 2x, then you're going to have this. X is greater than 4, x is less than 4. Piecewise functions, as I explained in our previous video, I said the function will be broken into different pieces, and each piece will have an interval it is going to be valid on. So this piece corresponds to this interval, this piece corresponds to this interval. So we have to find the limit as s approaches 4. Limit as s approaches 4 of this. And how do we get that? To get this, we simply find the right limit. So limit as x approaches 4, then you put plus. So what will be the right side of 4? That is this part, x greater than 4. And the solution is square root of x minus 4. So wherever we see x, we put what? 4 there. And that is going to give us square root of 4 minus what? 4, which will give us 0 as our solution. So meaning the right side of our 4 is going to give us 0 as our solution. Let's see the left side. That is limit as s approaches 4 from the left side. And that is going to give us this part, which is 8 minus 2x. And wherever you see x, you put 4. So 8 minus 2 multiplying 4, which is equal to 8 minus 8, and is equal to 0. You can see that the left and the right limits are giving us 0. Hence, the limit of the function as s approaches 4 is equal to 0. This brings us to the end of this class in finding the limits of stepwise and piecewise functions. In the next class, we're going to talk about determinate and indeterminate forms of limits. A case where you get undefined, what do we do? Then you look at the L'Hopital principles. Thank you for joining this class. Don't forget to share and like. And if it's your first time visiting this channel, don't forget to subscribe as well.